So this is the last part of the book. The author goes into try to explain or try to imagine how the governance of geoengineering and how coalitions that will perform geoengineering will evolve, and how other countries will respond, how natural disasters like volcanic eruptions will perturb Sahara rainfall or the monsoon and trigger some rogue activities, etc., etc., which I found to be not very convincing or persuasive, to use mild words. So I just will use this as a background to make some points that are I think more from the people who work on governance issues of geoengineering. Okay, so the Deliberate Planet starts by quoting Francis Spufford from Unapologetic: "Far more can be mended than you know." The book is actually about how Christianity and how Christianity can still be not a savior, but something that can still work in some sense for people who believe, who are faithful, let's say. Okay, so the point that is made also in the book that I will expand on using this figure on tipping points is that maybe there will be small scale specific focused geoengineering acts to protect some things, like, let's say, the Arctic ice that we talked about in terms of several ideas that had been discussed before. So this is, we can think of that in the context of this broader so-called tipping points in the Earth system, which are based on some paleo evidences and some heuristic arguments. And as you can imagine, these are called tipping points because they are points of irreversible change, which you would want to avoid by all means if you can. So here are some examples. The Greenland ice sheet disintegration, irreversible retreat of the ice sheet caused by rising temperatures, sea level rise impact is mentioned, permafrost loss, boreal forest shift, which it has happened, as we know, during ice ages, so that can cause ecological shift and regional warmings. Atlantic meridional overturning circulation, which I will show in the next slide, has happened in the past. Not a breakdown, but it has had significant perturbations which show up as signals around the world. We will see how that may work. Amazon rainforest dieback is now considered, and some people argue that it has already hit some kind of a tipping point. But one has to be careful because they are not easily modeled or predicted. So the arguments of having reached a tipping point can be somewhat theoretical. But there is data to show that Amazon may now be a net source of carbon instead of a net sink. There are West Antarctic ice sheet disintegrations that are happening, and just this week or the past week, I'm recording this on May what is the date? May 8th, which is a Saturday. So the past week there were articles in Science, I think, or Nature, about how multiple groups are looking at what are the extent of instabilities in these and when they may reach a point of disintegration and then massive sea level rise of up to 5 meters and so on. Of course, there will be West African monsoon shifts possible. About 9,000 to 6,000 years ago, there is good evidence that Sahara was very green, forced by orbital changes, orbital forcing. Civilizations had expanded beyond the Nile to Western Africa, and then as the rainfall changed and Sahara shifted back to a desert, civilizations collapsed back towards the Nile and so on. Indian monsoon shifts are argued based on deforestation or with let's say, geoengineering in the southern hemisphere, which would make the northern hemisphere drier, especially Sahel and Indian monsoon, coral reefs die offs, and so on and so forth. So can any of these be amenable to focused geoengineering solutions to prevent the tipping points? Obviously, just the argument, because it's not so easy to predict the tipping points, and if you are sure that you're approaching one and you decide to do geoengineering experiments to save them, then all the unintended consequences have to be tied down as well as possible based on the science, plus some sort of a global agreement has to be there to try such a thing. The so-called Thermo-Haline Circulation, or the Atlantic Meridional Overturning Circulation, includes the deep water formation in the Greenland, Iceland, Norwegian seas, Labrador seas, and then that water sinking and flowing south into the Southern Ocean, circulating and inundating the Indian and Pacific Oceans, converting to surface water and coming back south of Africa towards the sinking regions across the equator, going through these gyres and then the Gulf Stream and so on. And there is already plenty of evidence that seems to indicate that the specific lack of warming, or maybe even a slight cooling in this region, is potentially related to the perturbations of this global conveyor because of global warming. There are also other arguments, but there are also evidences. This cannot be directly measured, it's too slow, and it's kind of an integrated picture, and it's shown in the schematic. So directly measuring the perturbations to this circulation is not at all easy. Indirect inferences based on geochemical and other evidences indicates that we may be at its slowest phase in more than, I don't know, 20,000 years or so. And the slowing down basically means there is a reduced heat transport with this warm branch coming in the upper ocean, which would explain the lack of warming here. Okay, of course there are other dynamic responses involved, but you can see that there are also other regions which are already dynamically responding to global warming. So even if you make CO2 perturbations everywhere, the dynamics redistributes and creates these kind of warming patterns with the Arctic amplification that we talked about, and then other patterns here. Okay. And of course the Arctic Ocean, which is now considered a tipping point in terms of summer ice disappearing. Exact predictions are not available, but could there be some geoengineering experiments to try to save the Arctic ice from disappearing during summer months? Because if it disappears in the summer, then rebuilding in the winter will be harder. So if it survives the summer melt season, then obviously it can grow again in the winter season, and so on. So these are kind of theoretical arguments. Coming to the governance issues, the Carnegie Climate Geoengineering Governance Initiative was created in January 2017. So there is thought being given to this idea that geoengineering may become inevitable and has to be considered in the IPCC assessments and in some sort of experimental phase, at least to understand the processes that would be triggered by injections of, let's say, sulfur dioxide or sulfuric acid in the stratosphere, so that more understanding of the modeling and its projections can be done better. So the governing of carbon dioxide removal, here is the ideas that we discussed: fertilizing the ocean, enhanced weathering and ocean alkalinization, or enhanced ocean alkalinity enhancement, we called it, afforestation and restoration, direct carbon dioxide capture and storage, bioengineering with carbon capture and storage, soil carbon capture, sequestration, and biochar. So the shared governance challenges, including measurement and reporting, speed and scale of issues, potential public concerns, including transparency of information, accountability, investments in decision liability and compensation. So if countries that are not involved or in climate change or in these kind of geoengineering, if they end up paying a price with for unintended consequences, then how liability and will be assigned and how compensation will be offered. Specific governance challenges: managing the competition for land use and related impacts on the sustainable development goals at domestic and transboundary levels. We haven't talked about sustainable development goals, but this is something that's under the UN, evolved out of the Millennium Goals, and focuses on education, poverty, access, rights, climate justice, and so on. Managing risks and potential implication for biodiversity, addressing permanence of CO2 isolated from the atmosphere, so storage and sequestration. High costs: land use, capital, deployment, energy, mean policy signals, for example, carbon price on carbon or other regulations are needed. Another example, governing solar radiation. I won't go through these again because we already talked about it. Shared and specific governance challenges. Codes of conduct, guardrails, and public policy directions for research. Guardrails basically means going off a cliff and you're driving around mountains and sharp curves. There are guardrails. So how do we stay safely on our path? Assessing the risks and potential benefits to sustainable development in a risk framework. Monitoring, attribution, and management of risks and impacts. Potential public concerns, including transparency of information, accountability, involvement in decisions, liability, and compensation. And specifically, globally legitimate decision making on whether or not to research, to consider for use, to decide whether or not to deploy. Institutional guarantees against premature termination, and so on. Okay, so just to give you a sense that the community is already thinking about geoengineering and potential need for governance that will arise soon enough when things are tried even at experimental level at large enough scales. Okay, process studies being done by David Keith and Jim Anderson are too small, and they are not yet considered governance issues, but at some point, if it gets large enough, then what? So to end with the vision for the future, these are kind of figures you find in websites like inhabitat.com. You can see a highway here with artificial trees and windmills, and there are ideas for paving the roads with solar panels, which can take care of the weather elements. Melting snow can automatically change lanes and warn about hazards like animal crossing or accidents and so on. So obviously there is going to be this sort of local level modifications, which you can say mitigation efforts. So mitigation and geoengineering may kind of overlap in some scales and some aspects, as we talked about painting houses white or roof gardens and so on, for example. Fancy cars which are eco-friendly and maybe solar or biofuels or hybrid electric and so on. This is the smallest electric plane, which is going to be part of the systems, I'm sure. And this is a pedaled monorail, so you can see the people are pedaling around and propelling and transporting themselves, which is obviously going to be good for the environment, especially if in a life cycle it shows that it's carbon neutral or even carbon negative and so on and so forth. Okay, so with that we will conclude with this book, Planet Remade, and I will add material from another book which is much more directly science of geoengineering. I used this book to start with based on David Archer's recommendation and my own reading, to say that maybe coming from a journalist and a writer, it gives us a slightly different perspective than jumping into the technical details. So I hope it worked. Let's use the other book to add some more technical details. Okay.